maximum network quality. We are giving an array of network towers, where towers I is going to be the coordinates x and y, and another value q. Q, it just means quality. So denotes the ith network tower with location x and y and the quality factor of q. So all the coordinates are integral coordinates of the xy plane, and the distance between the coordinates is Euclidean distance. So up to now, what we didn't understand is the Euclidean distance maybe. So the Euclidean distance is calculated by xy minus x2 square plus y1 minus y2 square and the square root. So this is the Euclidean distance. We have to understand it. This is one formula we need to use. And secondly, we're going to have another formula. Let's just read it before we use another formula. So we are also giving an integer radius where tower is reachable if the distance is less than or equal to radius. So this is important. We are also giving a radius r. So we're going to check it is reachable or not. If the distance is inside the radius, so for example, this is the radius. So if this distance is outside the radius, it means it is not reachable. If it is inside the radius, it is reachable, less than or equal. Yeah, even it is equal to the r, it is at the border, it is also reachable. So this is just the definition, and we have to understand it because inside the formula we're going to use it. The signal quality of the ith tower at the coordinates x and y is calculated with the formula. So we're going to use another formula. So this formula is going to be q divided by 1 plus nd. Yeah. So this is d. So 1 plus d, and we're going to choose a floor. So the floor of this value. So this is another formula we're going to use. Yeah. So this is the signal quality of the ith tower. So the quality is calculated by this one. Yeah. The q is coming from the tower's I. So we have the q. And this d is just the distance from the tower to the, from the tower to, what is this called? I don't know. To the coordinates. Let's just say it is the coordinates. Maybe something. Yeah. Maybe a computer or something. Signal receiver or something. Yeah. So where d is the distance between the tower and its coordinates, the network quality at the coordinates is the sum of the signal qualities from all the reachable towers. So we're going to check all the reachable towers. It means everything going to be inside or at the border, but if it is outside, we will not count it. So we're going to return the array. So the array going to be at coordinates cx and cy, representing the integral coordinates where the network quality is maximum. Yeah, we just need to find such coordinates which one going to be the maximum. Yeah. So we're going to return the lexicographically minimum non-negative integer coordinate. So maybe we have the same value like 1, 2, and 2, 4. So definitely we're going to return 1, 2 because this is the lexicographically minimum. Yeah. Now I think it's enough for us to solve the problem. Yeah, but before we solve the problem, let's just check if we can use brute force. Likely for us we can use because the radius is 50 and the tower's length is 50 and the coordinates is also inside of 50. This means definitely we can use brute force to solve the problem. So the brute force idea is that we have the coordinates and we're going to be controlled from 0 to 50. So this is 50 and this is 50 because all the coordinates will be in this kind of 0 to 50 areas. So if this is the coordinates where we should set the tower station, can we set it here? Or can we set it here? Or can we set it here? So according to the machine learning, if you did some machine learning, normally this point would be something in between. Because even for this point, the quality is going to be different. Maybe this quality is bigger, it means it is more important. So this point is going to be closer to the bigger quality areas. But no matter how, this point would be in the middle. I mean, in the middle of all those points areas. So normally this point is going to be from 0 to 50 and 0 to 50 for the coordinates. This means we can use brute force to solve it. Instead of outside this areas, the tower station should be from 0 to 50, and 0 to 50 should be inside these areas. So this is going to be the tower station. Now we can solve the problem by using the brute force. So let me prepare n going to be 51. This is because the coordinates is from 0 to 50, so we're going to set 51 because we're going to use a loop. So for I, let's say maybe I, yeah, for I in range capital N, and for j in range capital N, this is the brute force to checking the tower station presence. Yeah, but we need to prepare a final result. Let's let's just set the final result to be 0, 0 because we don't know, and let's set a maximum value from 0 because we're gonna check the maximum value. If this value is more than the maximum value, we're gonna update the coordinates result. Yeah, so from here we're gonna set the quantity, the total sum. The quantity gonna be for one of the so the quantity gonna be the total sum from this station to all other coordinates. It can be many coordinates, we don't know. It's gonna be length of the towers. It's gonna be something like 50 coordinates, but we don't know. So here we're gonna use this ij. We're gonna check the quantity q. So if the quantity q is more than the maximum quality, this means we're gonna update the maximum quality to q, and we're gonna update the result. It's gonna be I and j. So finally, if everything is okay, we're gonna return this result, because according to the problem, definitely we can find such points. Definitely we can find it. Yeah, only we need to consider the lexicographic minimum. Because we are using a for loop ij, it's gonna always be starting from 0. So this means if we find it, definitely it is the lexicographically minimum value. Yeah, minimum coordinates. So now what left behind is the check function. Actually, it's going to be x and y, the coordinates. And let me just prepare a final result. It's going to be 0, and finally, we're going to return this result. It's going to be the total sum of the quality. So for x2, y2, and let's say it's going to be a quality inside of the towers. Let's just check the distance. So the distance is going to be, as I said before, it's going to be the formula plus y minus y2 square. So this distance is a square. Actually, it is not the real distance, right? Yeah, but this is safe for mathematical calculation. We have to use a square first, otherwise we're gonna make mistakes. Yeah, because in mathematics and in programming, if the distance is only a little bit, but it's gonna have a big influence. So for example, the distance is 0.00001 difference, 0.00 something 1, and for the machine learning calculation, it's gonna have a big influence. So this means before here, we're gonna prepare the distance as a square root. So this is gonna be safe. So if this square root is less than or equal to the radius times the square of 2. Yeah, so basically this means we're gonna use a square to calculate, and then we're gonna use the square root to check the distance. Yeah. So this means if the distance is with inside, if the distance is okay, so we're gonna use the formula to update the result. So the formula is gonna be integer. So because here is a floor is basically integer. So it is a qi. So what is the qi? It is from the q. Yeah. Divided by what? It is 1 plus the square root of the distance. Yeah. It's gonna be square root of d. So I think that's all about it. We have to be careful about such kind of calculations. Let me just run it. As you can see, it works. And now let me just submit it. As you can see, it works, and it's passed for all testing cases, and it's pretty fast. and the time complexity is n cubic, because from here this is n square, and from here we use another for loop, so this is why it is n cubic, and this is why it works. I think that's all about it. Thanks for watching. See you next time.